Okay, so we're starting out this week with a hopefully relatively simple set. It doesn't really have any special techniques. So we're just gonna start talking about these next week. We will have something that's a little bit um, a little bit more advanced, I think, but we'll see what happens next week. So for now, I'm gonna just go through how I do the problems of this week. And even if you've done it, you might still want to look at it just in case, maybe I've done something that's a different technique or use something else that you haven't heard of before. So anyway, so let's get right to it. So the first problem, you have a farm, and the farm has a cow, and the cow, they want to set up a fence around the pasture. You're given the area of the pasture. Oh, by the way, it says a square-shaped pasture. So you're given the area, how long a fence does old McDonald need? Input consider single integer a from 1 to 10 to 18, the area of square meters of old McDonald's pasture. Output the total length of fence needed in meters. The length should be accurate to an absolute or relative area to 10 to the minus 6. Okay, so let's talk about what's going on here. Right, so you have a square. They give you the area A, and the perimeter, the fence, it's basically the side, whatever the side is, times 4. Well, if this area of the square is A, then S squared must be A, or in other words, S is equal to square root of A. So the answer is simply square root of A times 4. Okay, and you can see in my code here, right, that's all I do. I multiply by 4 times A, and then that's it. Now, as simple as this, I want to make sure that we dissect this just to be a little bit safe here. The first thing is it tells you that the input consists of a single integer A. And immediately, some people might start writing int A, and that would be a big mistake because they then tell you that A is up to 10 to the 18. Okay, for a normal integer with nothing special added to it, it's 32 bits, and that's up to about 2 billion or 2 times 10 to the 9. So if you just use an int, this will be not big enough. It will just be an integer overflow. So at the very least, you should put a 64-bit integer, which is long. But you actually don't need to keep things as integer because your answer is going to be floating point anyway. So you might as well just use a floating point to read in the A. And if you are concerned about the fact that 10 to the 18 has 18 digits and double doesn't have 18 digits, you can use long double, which is a quadruple precision floating point numbers. So just in case you don't know this, you can look up IEEE 754. That's the floating point format. And basically, if you use floats, it will be what's considered a single precision here. And double precision is double, and then quadruple is long double. So it will tell you how many digits there are, but these digits are in binary, so in decimal. Double precision is about 16 digits, and long double has about 34 digits. Now we only need, okay, so now let's see. It says that the output should be accurate to a absolute or relative error of at most 10 to the minus 6. What the heck does that mean? Absolute error just means that your answers should be correct up to 6 decimal places. So if you're correct up to 6 decimal places, you're good. But what about this relative error? Sometimes the answer can be really, really small. Maybe the correct answer is, I don't know, 10 to the minus 10. And in that case, if you just say it's correct up to 6 digits, then 0 is the right answer, because it's one of the right answers. But relative error means that the number of significant digits that are correct, it's 6. actually 7 because it's to -6. So anyway, the point is, even though double only has 15 digits of accuracy, that is still good enough because we only need 6. And then the only other thing that you might not have seen before is that if you use fixed here, that will make sure that you don't print in scientific notation. You always print a number, integer dot decimal places, and then set precision says how many digits of precision you produce. If you don't put fixed, then set precision will potentially give you scientific notation with 10 significant digits. Doesn't really matter if you use fixed or not, I guess, but it's often easier to see. So anyway, that's how you would solve this problem. Okay, so that's the main thing, is that even though this is a relatively simple arithmetic problem, you want to look at all the bounds, all the requirements of the output, and make sure that whatever you need to do is actually going to be good enough. Okay, so that's that one. So let's look at the next one, code to save life. Okay, so basically, I'm sure you can read this problem on your own, but basically you have these numbers, so you have the first number is how many cases you have, and each case comes with a pair of numbers. This is 345, and this is 567. And basically, the only thing you have to do is add numbers, except that the numbers comes in a strange form where the numbers have spaces in between, the digits have spaces in between. And then you also have to print out the answer in this form, which has digits in between. Okay. Now you might have to say, well, what if somehow things are 0? Can you add 0 plus 0 together? They don't tell you that it never happens. So you just have to be careful about that. Okay, they don't show you an example, but they also don't tell you that you cannot have zeros. So you just have to make sure. Oh, wait, hang on. It does say positive numerically and positive numerically. So these numbers cannot be zero, so you don't have to worry about how should you print 0. Can you have a bunch of zeros and have it 0? Okay, so the idea is there are many ways you can do this. Is basically what you have to do is read each line, turn it into a number, add it, and then turn it back into an output in this form. And because they tell you that they're at most 9 digits, then a normal integer would be good enough, because then you take two numbers of 9 digits, the most you can have. When you add them together, still less than 2 times 10 to the 10. Actually, 9 digits is only 10 to the 8. Okay, so, and you add them together, 2 numbers that are at most 9 times 10 to the 8 is at most 2 times 10 to the 9. Okay, maybe I should write this down just so that it's easier to see. Okay, so 9 digits means that each number is at most 10 to the 8. 9 times 10 to the 8, I should say. So why not just write less than 10 to the 9? Right? 10 to the 9 is 1 with 9 zeros after. So every number that they give you is at most this much. So when you add 2 of these together, it's less than, so the sum is less than 2 times 10 to the 9, or in other words, this, which is less than 2 to the 31 minus 1, which is int max. So basically, the main thing is you want to make sure that a normal integer is good enough to store this. And then the remaining part is try to figure out how to deal with the input and output. So let's look at how I do this. All right, so let's read this here. So first I read in the number of cases, right? Read in the number of cases. And I have this cin.ignore 1. What the heck is going on? So the input looks like this, 1, enter. Oh, maybe I should write it in this way, 1, followed by the new line character. Then you'll have 2 space 3 space 4 new line, and then maybe 1 space 2 space 3 like that, and then N of 5 at the end. This is sort of what it looks like if you show all the hidden characters. So when you read the T, this will go to T, but the cursor would be here if you think about cursor where it's going to read next. And what I'm going to do for the remainder of this is to read things one line at a time. How do I know it's one line at a time? It's because I see a new line. I'm going to read until I see a new line. And if I don't eat this up, then I'm going to read this and I'm going to say, oh, that's the end already. So I need to get rid of this and advance my cursor to the next one, which is why I do C and dot ignore 1. So anytime you read with this dot extraction operator is what it's called, it will leave you at the next space, whether it's new line, blank, new line, space, or whatever. And if you then try to write sort of line-oriented input like this, and you try to read until the end of line, you have to take care of this hanging new line character. Otherwise, you'll get fooled by this and think that there's an empty line coming. So the trick is to use C and dot ignore 1, and that will get rid of the next character. Alternatively, you can just use get line and read it in a string and stow it away. That's also the same. And then this is just a loop that goes through whatever number of cases and calls solve. So solve is the thing that does, okay, so solve, what does it do? It calls get ins, it reads in an integer in a line, call gets in again and add it to the answer and then write it out. Okay, so the magic happens on get ins and write ins. So let's look at get ins. I start with 0. I start with x equal to 0. And I'm going to read, basically, if I have my input, it's going to be like this. I'm going to read pairs of characters. Okay, the first character in a pair is going to be a digit to come. And the second character in a pair is either going to be space or new line. Space means keep going, new line means quit. So I have this, even though it says a while true, so it looks like an if loop, I'm actually checking if I'm breaking if the second character in my pair, it's a new line. Okay, so this is a little bit unconventional loop that I break in the middle. I break at the end and not at the top. So anyhow, I guess I can also write it as a do-while loop, but I hate to think about do-while loop, so I don't do it this way. Anyway, I read a character. Then I figure out the character -0, that would give me the digit value. So because these, remember, it's when you read it in, it's not the number 2, but the character 2. So when you subtract the 0 character, the ASCII value 2 minus the ASCII value 0 will actually give you 2. And then I take whatever I've accumulated times 10. So if I have already accumulated something like this, times 10 will just add a 0 at the end and then add the next digit into here. So in other words, I shift everybody to the left by 1 position and incorporate the next digit. Actually, because these digits are numbers that are separated by space, you could have just used C and arrow. If you use C and arrow the digits where digit is D, that's also going to work. Okay, but anyway, I decided to use characters everywhere because I was already using characters, so it's easier for me to just think about one type. Anyhow, so that's incorporate the next digit with this multiplied by 10 and add the digit. I read the next digit in the pair. It's either space or new line. If it's a new line, I break. Otherwise, I keep going, and I keep going until I break, until I get the new line, and then I just return x. And that's how I get the input. There are other ways you can kill this part. You can read in the whole string. You can remove this. You can remove the spaces and convert to integer. Whatever you want. There are other different ways you can do this. What about writing an integer? So if I'm writing an integer, all right, 1, 2, 3, 4, what I want to do is to pick up the digits one at a time. And the standard way to pick up a digit is that if x is an integer, then x mod 10 is the last digit, and x divided by 10 is the rest of it. And you would then repeat. So you then say x is equals to this, and then you repeat the same thing. And you keep doing that. And then finally, you will get 0. And that's when you stop. And you print all of the remainders mod 10, but you have to print it in reverse order. So what I'm going to do is I'm going to make use of recursion. I'm going to say, go and recurse on x divided by 10, print that out. So this is my recursion. And then when I'm done, then I print the last digit. And because of the way I place this recursive call first, before I print the last digit, I will end up printing things backwards. Okay, so that's a little trick. The only thing that you have to worry about is what do you do with this 0? When you stop, do you print the 0 and do you not print the 0? Right? If it's 1, 2, 3, 4, when you get the 0, you should stop. You should not print it. When I did this problem, I didn't actually even see the fact that you cannot have 0. So I actually took into effect, what if x is 0 to begin with? And that's where I have this Boolean flag to say if you just got past 0 at the very beginning, then you have to print the 0. Otherwise, you don't. But in any case, I guess actually this is not necessary. And then here, I just see if the very first time you call it, if you're the last digit, then you print a new line after this. Otherwise, you don't. You print a space. So this is how I end up printing 1 space, 2 space, 3 space, 4 new line. Okay, so this is how I did it. By the way, in case you didn't know, let me just, if you go to GitHub, my repository, so Howard Cheng ULETH/contest, this is a public repository, and I put my solutions to many problems, and in particular, the problems that I signed for weekly contests are here. So if you go to Caddis, you will see all of these problems. If you want to peek, of course, you shouldn't peek until you try it as yourself and so on. But if you want to peek, you can go and look up my solutions. I can't guarantee that they're the best solutions, and I definitely probably will not have any comments, but you can look at it if you want. Okay. Anyway. Okay, so that's that one. Let's see which one. Okay, let's look at what does the Fox say first. All right, so again, you can read the problem, but basically, the first line of input is the number of test cases, and then a bunch of test cases follows. The first line contains the recording, which is a bunch of words over lowercase alphabet separated by spaces, each containing at most 1 character, no more than 100 words. So it's a bunch of these animal sounds, I guess. And then you have a bunch of animals that says animals go, dog goes woof, fish goes blub, and so on. And those are the things, those are the words that are not what the fox say. And then the idea is that you have to basically look at this list that they give you in the first line and remove or print only the ones that are not any animals that they have mentioned. So the idea is basically that you have to read this, you have to remember this line, this set of text, and then you just keep on reading these and then remember that these are the ones that you don't want to print, and then you go back to these lines, the first line, And for each word that is not one of the animal sounds, then you have to go and print it out. And that's basically what you have to do. So it comes in sort of two parts. The first part is how to parse this input. And then the second part is how do you actually deal with this, deal with these words. And then remember which ones you don't print. Okay, so again, I do the same thing. I read in the number of cases, ignore. So if ignore, actually ignore without a parameter, just ignore to the end of the line. So that's another way. And then I have this loop that just calls it one case at a time. So let's look at what we do each case. The first thing I do, so why do I ignore? Because again, I switch from reading the number of cases to reading one line at a time. So I got to get rid of that hanging new line after the case number. So the first thing is I'm going to read the line, but this line contains a bunch of words. I cannot just read a bunch of words with C and arrow because I would not be able to stop. I do not know when to stop. I have to use getLine to read the whole line. And then I'm going to use iString. This is something that allows me to take the string and convert it to an input stream, just like sort of like cin. And that will take the contents of that line and have it act like cin when you read it. So the next loop will make it clear. I have a string variable for each word. I'm going to have a vector of strings that is the recording that's going to store the recording. And then let me do not disturb. And then I'm just going to say, wow, from this iString stream that I created, wow, I can read a word. So in other words, I keep reading words separated by spaces in this string until I have end of file. And end of file in this case just means that my string is exhausted. For each word that I read, I put it in the recording. So that's what I do. Then the next thing is, now that I've processed the first line of recording, I'm going to read all the animal sounds. So I'm going to have a set containing all the words that I don't want to use because they are the animal sounds. So what am I going to do? I'm going to, again, while I can read another line, and the line doesn't say what does the fox say. So it says what does the fox say, that's the time for me to stop. Again, I'm going to break it. I'm going to use iString stream to create a new iString stream with this 9 that I just read. And I'm going to break it up into these 3 components. The animal, and then goes, and then W, and then the sound. I actually don't care about the animal or the goes. I only care about this. So I just insert the word into my bad list. And then at the end, all I'm going to do is I'm going to go to my recording again. For every word, I check. I say in this set, is the count of the word in this set 0. So it's either 0 or 1 because it's a set. 1 means it's in the set. 0 means it's not. So if it's not in the set, then I print it. If it's in the set, I don't do anything. Okay, so this problem, it's mainly an exercise in breaking things up into strings and also perhaps using a set. Now, you don't have to use a set because everything is only at most 100 animals, 100 sounds and all that stuff. So you could actually, instead of using a set, you could use an array to store the bad words, and you can use linear search every time. It's not going to be a problem in terms of runtime, but you might as well use what's provided by STL. It makes things easier anyway. Okay, so that's how I would do this one. 50 shades of pink. Okay, so here it's another string parsing exercise. So you have a n number of words. Each of the n lines is a color name. They are up to 30 letters, either capital A to Z or little a to Z. Print one integer, the number of training sessions if he can. Because there are no pink buttons, output is standard. Excuse me, I'm going to watch Star Wars with my daughter. So what is pink? Pink means that either the word pink or rose somewhere in the name. Okay, so we're looking for substring of pink and rose, but you have to worry about upper and lower case. So the easiest thing to do actually is to just convert everything either to uppercase or lowercase before you do the search. That would make things a lot easier. Otherwise, you have to consider all possible upper and lowercase variation, which is going to be much harder. So 50 Shades, it's here. So this is, I guess, an exercise in STL. I read in the number of words, and this time I don't bother using ignore. Why? Because I'm not using get lines. I'm just reading strings with the same extraction operator, so that would separate things by space too, so I don't have to worry about it. Answer is going to store how many words I find that has pink or rose. So what I do, I read in the string, and I'm going to use STL to convert everything to lowercase. Now, transform will take a container, which in this case is the string, begin and end of the string, and put it back to the beginning. That's the output iterator. And the function to apply is toLower. And toLower requires colon, colon. This is one of those strange functions in STL that if you don't use colon, colon, it wouldn't know that it's a function. There's a long history of what the heck I just mean. It turns out if you do this, it won't work. But if you do this, it will work. If you're interested in the history of why that is, feel free to send me a message. I can explain all of that with references. But if you don't want to know, you can just use this. Okay, normally other functions don't require this colon, colon. It just means use the global one. But for some reason, toLower required toLower, toUpper, and those things requires. Anyway, this will transform everything to lowercase. So now I only have to look for rose and pink in lowercase. So I say if s.find rose, so this is string search, looking for the substring rose, it will return a number giving the index of the first occurrence, or this special constant, string colon, colon, end post, not a position, which means it's not found. And so I have to check that it's not, you cannot find pink, or you cannot find rose. Sorry, wait. Sorry, I got it inverted. Not equals means, so if it's equals, it means it cannot be found. So not equals means it can be found. So if the return is not the invalid position, it means it's found. So if you can either find rose or find pink, then I increment. And I remember that I have found one more word. And then at the end, I just ask, if this is non-zero, I print it out. Otherwise, I print out the string that indicate that I cannot find. Okay, so you can do it again in many different ways, of course, but being able to use the STL can make it a lot faster. Not necessarily a lot faster to write, but a lot faster. So not necessarily a lot faster to run, but certainly a lot faster to write if you're familiar with STL. Okay, so the last one is planting trees. The code is actually fairly short, but maybe we need to look at the problem a little bit more. Okay, Farmer John has recently bought N tree seedlings that he wants to plant in his yard. It takes 1 day for John to plant a seedling, and for each tree, John knows exactly in how many days after planting it grows to full maturity. John would also like to throw a party for his farmer friends, but in order to impress them, he would like to organize a party only after all the trees have grown. More precisely, the party can be organized at the earliest on the next day after the last tree has grown up. Help John to find out when is the earliest day when the party can take place. John can choose the order of the planting the trees he likes. So he wants to plant the trees in such a way that the party will be as soon as possible. The input consists of 2 lines. First line contains a single integer n, denoting the number of seedlings. Then a line with n integers ti follow up to 1,000,000. Each ti denotes the number of days it takes for the ith tree to grow. Your program should output exactly 1 line containing 1 integer denoting the earliest day when the party can be organized. Days and number 1, 2, 3, and so on, beginning from the current moment. All right. So if you have a tree that takes Ti, let's say Ti is 10, just to make it concrete, and you plant it on day 5, that's the day you plant it, then according to this, it's going to show up mature on day 15. Okay. If you have another tree on day, that's, I don't know, time 4, and you plant it on day 6, then mature is going to be 10. And the important thing to notice is that even though I planted a tree later, I can actually mature early. So if you think about this, if you want to have all the trees mature as early as possible, what do you want to do with the tree that takes the longest to grow? Do you want to delay planting it? No, you actually want to plant it as early as possible, because making it any further would only cause your tree to grow longer, take longer to grow. And the tree that takes short to grow, you want to plant it later. So let's think about it this way. Let's imagine that I have 2 trees. Let's just call it Ti and Ti plus 1. So I have a bunch of trees, and I'm just going to look at 2 of them. Just take 2 of them that are in sequence. And I decide to plant it on day, I don't know, day 5 and day 6. It doesn't actually matter, but I decide to plant these 2 trees in consecutive days. Then the maturing date to the planting date, then the mature date, it's 5 plus Ti and 6 plus Ti plus 1. If I plant the smaller tree earlier, then this is going to be less. And so the maximum, if I want to wait until both of these trees mature, it's going to be 6 plus Ti plus 1. Right? Because I have to wait for the longer, because I plant this one later, and this is the more mature. And this takes longer to mature. So the mature date for both of these trees is going to be dominated by the one that I planted last, because it's also the longest. On the other hand, if it was the other way around, now it may be this way, because these are integers. So because these are integers, if, for example, this is 10, then this has to be at least 11. And when I add them up, this is actually going to be bigger than or equal to this. And the maximum, the maximum takes to mature, it's actually going to be this one, which might be a little bit smaller. Why? Because this is the early day. But the most important thing is that if I did it the other way, it was 6 plus Ti plus 1. And now it is 5 plus Ti plus 1. So by switching the order to plant the larger tree, the larger tree earlier. Okay, I'm kind of mixing things up here. So this is, I guess, sorry, I got mixed up with my indices. By planting earlier, okay, planting larger one earlier, I'm able to get these 2 to mature a little bit early. So what am I trying to say? Okay. So if you look at the days that you plant the trees, 1, 2, 3, 4, 5, 6, and then the trees TI that you plant, maybe you plant a 10 and 4, 3 and 4 and 7 and 2 and 6. Maybe this is how you decide to plant. Well, by switching these two because they're out of order, you are guaranteed to either make it better or at least no worse. And similarly, anytime you see a pair that is out of order, where it's I guess in order actually, you want to make it out of order so the bigger one comes first. It will causally improve the mature time to make it earlier, but you not make it any worse. And basically, you can do this kind of like bubble sorts. As every time you see a pair that is in order, you can swap them and make it into a completely sorted in reverse list. And that it's a list that cannot be improved any further. Because whatever you switch, it can only be worse. And definitely not better. It cannot maybe the same, but it cannot be better. So the idea is that you want what we call greedy algorithm, which is to greedily plant the one that is going to take the longest to mature as early as possible. Intuitively, that makes sense, but what I kind of show you is a bit of a, I don't know, like would go so far to call it proof, but a mathematical argument reasoning on why that works. And usually with a lot of these greedy algorithms, once you see this trick, the implementation is relatively simple, right? So you read in everything, you sort it. So this sorted from smallest to largest. And then I'm just going through and I'm reading the array backwards. So this gets the largest to smallest. And that will basically, for each tree, I plot it as early as possible, the day plus the length, the time of the tree to mature. And I take the maximum, that would be the last day that any tree will mature. And then the answer is just whatever the last maturity date is plus 1, because you want to hold the party the next day. Okay, so anyway, that's the solutions for this week's set. If you have any questions, please feel free to reach out to me through Discord or email. And I guess I'll post the next set next, I guess, Wednesday at 9 a.m. All right, I'll stop now.